Good morning, student. So we have seen in the first chapter, that is physical world. The next one, the important topic is fundamental forces in nature, nature of physical laws here. So here the concept map is given. So in this case, we will discuss about the fundamental forces. Okay, the fundamental forces you can see here. The fundamental forces here, the strong nuclear force, then you can say the weak nuclear force, then electromagnetic force, weak nuclear force, and the gravitational force. These 4 points we have to see here. So the fundamental forces in nature. The first one is here, you can say the strong force, strong one, electromagnetic one, then weak nuclear force and gravitational force. So you can see here the different in this particular chart, the strong nuclear force is held in the nucleus. Then if the force which holds nucleus together, that force is responsible, that is the nuclear force, which is very strong. Then here electromagnetic force is there, then weak nuclear forces is there, and gravitational force, you know very well about the gravitational force. So the strong nuclear forces, if you take the atom, then in atom you are having the neutron and proton. These neutron and proton are held together inside the nucleus by means of exchange of meson particles. Actually, Yukawa was the first scientist. He has given about this concept. So what is meant by this exchange of particles here? Now you see here you can see the pi mesons are there. So proton and neutrons are there. Actually there are three types, pi plus, pi minus mesons are there. So the exchange of meson, due to the exchange of meson particles, these proton and neutrons are held together inside the nucleus. Now he has correlated by giving a very simple and beautiful example. For example, if you are having two dogs and a piece of bone there, then the two dogs will always try to snatch that bone towards each other. That means if one dog will snatch the piece of bone from the another one, then the another dog will also try to snatch that bone from the first dog. So that means that bone will keep these dogs bound together by exchange of that bones from one dog to another one, you can say. Similarly, the exchange of mesons is responsible for the, you can say, the holding of this proton and neutron together in the nucleus, and for that one, that force is very strong force here, you can see. The range of the particle of the exchange force is limited by the Earth's uncertainty principle. It is the strongest of the four fundamental forces. So this force is very strong force. Next one, the electromagnetic force. In electromagnetic force, one of the four fundamental forces here. So the electromagnetic force manifests itself through the forces between the charges, that is Coulomb's law. What is this Coulomb's law here? That means if you are having the two charges, suppose Q1 and Q2, you are having the two charges, then these two charges are either repelled or attracted by the force, and that is called as the Coulomb's force. And that Coulomb's force is given by F is equal to K into Q1 Q2 upon R square, where you can say this force, Coulomb's force is directly proportional to the product of the charges Q1 and Q2, and it is inversely proportional to the square of the distance between them. So this formula I have written here, where this K is called as value of the K is here 1 upon 4 pi epsilon naught is the value of the K here. So that force is equal to K into Q1 Q2 upon R square is called as a, you can say, the Coulomb's law, Coulomb's force, which is called as the electromagnetic force. Next one is the weak force. One of the fundamental force, this is also one of the four fundamental forces. Out of that one, the weak interaction involves the exchange of the intermediate vector bosons, the W and Z. Since the mass of these particles is of the order of 80 gigaelectron volt, the uncertainty principle indicates the range of about 10 to the power minus 18 meters, which is about 1% of the diameter of the proton. The weak interaction changes one flavor of quark into another one. For example, in the neutron decay depicted by the Feynman diagram by at left above, the one down quark is changed to the up quark. Actually, there are different types of quark, up quark, down quark, etc. So the transforming the neutron into a proton one. Next one, gravitational force. Already you are familiar with this force. That is, suppose small m or m1 and m2 are the masses here. m1 and m2 are the masses of the object. Then the gravitational force F is directly proportional to the product of the masses. This one I will write in the very exact manner. The gravitation, that force between the two objects is directly proportional to the product of the masses m1 m2, and that force is inversely proportional to the square of the distance between them. So no doubt this force is the central seeking force. It always acts the line joining the two centers of the object. So from this 2 you can write F is equal to capital G into m1 m2 upon r square, where the G is called as the universal gravitational constant. So this is called as the gravitational force. Next one is the weak force. The kind of interaction is not well understood yet. Its range is shorter than the, you can say, the nuclear force. It is important only for certain nuclear processes like radioactive beta decay. Now, strong nuclear force, electromagnetic force, weak nuclear force, and gravitational force. The relation is given by this particular ratio: 10s to 2, s/1, s/10 - 12, s/10 - 36, etc. is given here. Next one, comparison of electrostatic and gravitational force. What is the point of similarity? They are central forces. Just I told you, the gravitational force and electrostatic forces are central forces. That means they are acting along the line joining the two charges or the two bodies. They obey the inverse law. That means they are inversely proportional to the square of the distance between them. They are conservative forces. They operate even in vacuum also. Next one, point of dissimilarity. Gravitational force are the attractive, while electrostatic forces may be attractive or repulsive, depends on the charges which you are considering. Gravitational constants of proportionality doesn't depend on the medium, while electrostatic constant depends on the medium. That means whatever the value of G you are taking, so for that one, medium is not at all important. Here you can say that gravitational constant doesn't depends on the medium, but if you take that gravitational, that is constant k, or 1 upon 4 pi epsilon naught in case of Coulomb's law or Coulomb's force, then it depends on the medium, in between the two charges. So electromagnetic forces are extremely large as compared to the gravitational forces. So this diagram gives you about the strong nuclear force, electromagnetic force, weak nuclear force, and gravitational force. So these are the 4 diagrams here: strong nuclear force, electromagnetic force, then weak nuclear force, and gravitational force here. Next, the conservation laws. Law of conservation of energy. The law of conservation of energy implies that the energy cannot be created, not be destroyed, but it can be converted from one form to another form. These are very simple things. You have always studied about this conservation of energy from the 9th standard also. So you can say you can convert kinetic energy into potential energy, or different forms of energy you can convert into different forms of energy. But in all, the energy can neither be created, not be destroyed, but it can be converted from one form to another form. So these diagrams gives about the conservation of momentum, conservation of energy, conservation of angular momentum here. So conservation of momentum, conservation of conservation of energy, and conservation of angular momentum. So here the famous equation given by the Einstein, E is equal to mc square, which is used for the conservation of energy. Then mechanics problem, solving the problem, you have to use the conservation of energy things here. Then work energy principle is also based on this one. It rolls as a fundamental principle also. Now the conservation of angular momentum, we will study this one in the next slide. So conservation of linear momentum. Law of conservation of linear momentum. If no external force acts on a system of colliding object, then the total momentum before collision is equal to total momentum after collision in the same direction. So I think you have derived this particular derivation also in the 9th class. So when the two bodies, suppose this body having mass m1 and another body is having mass m2, this one is having certain greater velocity and this is having some smaller velocity, then this will collide on this one. So the collision will take place, and after collision this will collide on this one, or this will apply force on this one. So you can say these two body A and B, they will collide here. So this force will be FEB, this force, and this force will be FBA. That means the force exerted by A on B and the force exerted by B on A, and then they will get separate in such a way that the A is having a smaller velocity and you can say B is having a greater velocity. So we have derived this one, the total linear momentum m1 u1. Suppose u1 is the velocity here, and here you can say u2 is the velocity here, and v1 is the velocity here, v2 is velocity here. So m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This is nothing but your statement of the law of conservation of linear momentum. So these are the flowcharts which gives about the law of conservation of momentum. So you can go through this flowchart, you will understand each and everything which is expressed in this particular flowchart. Now the law of conservation of angular momentum. Law of conservation of angular momentum, if no external torque is nothing but what? Turning effect, acts upon a system, then the angular momentum of system remains constant. Conservation of angular momentum of rotating body is analogous to the conservation of linear momentum. Angular momentum is a vector quantity whose conservation expresses the law that a body or a system that is rotating continues to rotate at the same rate unless a twisting force called a torque is applied on it. In angular momentum of each bit of matter consists of the product of its mass, its distance from the axis of rotation. I think this one also you will study in case of your rotational dynamics about this law of conservation of angular momentum. So this is also flowchart which is related with the law of conservation of angular momentum here. Next one is the law of conservation of mass. Law of conservation of mass implies that matter can be neither be created nor be destroyed. The process, that is the process of the change in the physical or the chemical properties of the substance within the isolated system, such as conservation of the liquid, that is conversion of liquid into gases. This is called the, you can say in isolated system the chemical process will take place like this one. So the, you can say that in the within the isolated system, this such as the conversion of liquid to a gases leaves the total mass unchanged. Strictly speaking, mass is not a conserved quantity, but however, except in nuclear reaction, the conservation of rest mass into other forms of energy mass is so small that the high degree of precision rest mass may be tough as of rest mass may be thought of as a conserved one. So these are related to the law of conservation of mass. Law of conservation of charge. Law of conservation of charge states that the total amount of electric charge in an isolated system does not change with the time. As a subatomic level, charge particle can be created but always in a pair with equal positive and negative charges, so that the total amount of charge always remains constant. So conservation of charge, let us example is that suppose you are having a glass rod and if you are having a silk, then if you rub the glass rod on the silk, then the number of electrons or the number of electrons will transfer from one body to another body, so that the glass rod will become the positive charge and the silk becomes the negative charge. But the total charges before the rubbing process and the total charges transferred after the rubbing process will be same. That's why the law of conservation of charge will takes place there. So in particle physics, other conservations laws apply to certain properties of nuclear particles, such as Valence number, lepton number, and the straightness. Such laws applies in the addition to those of mass, energy, and momentum encountered in everyday life, and may be bought of an analogous to the conservation of electric charges. So these are the things which are related with the electric charges. In case this law can be very nicely explained with the help of the frictional you can say frictional electricity or frictional process. So I hope students, in this particular topic today, what we have discussed: law of conservation of charge, law of conservation of mass, then law of conservation of angular momentum, law of conservation of linear momentum, then conservation of energy, then the four laws, that is strong nuclear force, electromagnetic force, weak nuclear force, and gravitational force, and the relation between them. So I request you to go through the topic from your textbook and try to note down in your copy, and again try to understand these concepts related with the four forces, which are four forces, and also the law of conservation of linear momentum, then angular momentum, law of conservation of energy, law of conservation of charge, and law of conservation of mass. Thank you very much.